All right, here we go, friends. 11.5, can you add and subtract radicals? First of all, you must have like terms. Okay, right here, you must have like terms. This is super important. You cannot add and subtract if they are not like terms. Now, what does like term mean? Well, like term means you have the same radicand, okay, which is the number inside the radical, and you have the same index. Okay, so if I'm looking at this, I can add the square root of 2 plus the square root of 2. I can add that. I cannot add the square root of 2 plus the square root of 3. I cannot add that. Okay? Yes. No. Yes. No. Okay? Does everybody see that? So let's look right here at our adding and subtracting radical rules. Simplify each radical as much as you can. Then combine like radicals by adding or subtracting their rational factors. So when we add and subtract radicals, I like to think of the radical itself like a variable. So let's use my square root of 2 plus my square root of 2. I'm going to think of that square root of 2 like an x. If I had x plus x, it would be 2x. So if I have square root of 2 plus square root of 2, I have 2 square roots of 2. Okay? And that's why I cannot add square root of 2 plus square root of 3. All right, so let's look at example number 1 right here. Here's example number 1. First of all, can we add them? Do we have the same index? Remember, index is the little thing that sits inside the check mark. Yes, we have the same index. Now, do we have the same radicand, the number underneath the square root? Yes, we have the same radicand. So we can add these together. So I have 4 square roots of 3 plus 2 square roots of 3 gives me 6 square roots of 3. And that's my answer. So let's look at example number 2. Example number 2. Now first look, no, we can't combine any of these. Uh-oh, we can't combine any of these. Oh, yeah, you can. Yeah, you can. So the first thing we're going to do is we're going to simplify these, just like we've been doing before. So I'm going to take 45 and I'm going to break it down. 45 breaks down into 9 times 5. 9 breaks down into 3 times 3 times 5. Oh, takes 2 to bring 1 out. 3 square roots of 5. Let's break the 18 down. 18 breaks down into 9 times 2. 9 breaks down into 3 times 3 times 2. Oh, so that becomes 3 square roots of 2. Takes 2 to bring 1 out. Minus square root of 5. Oh, looky. I've got 3 square roots of 5 minus 1 square root of 5. That leaves me with 2 square roots of 5 plus 3 square roots of 2. I can't combine those, so I am done. Unless your problem says get a decimal approximation, which this one does not, so we are done. Okay, so the ones on this slide look a little bit trickier, tricky. Same rule though, has to have the same index and it has to have the same radicand. Okay, well first of all, none of the radicands in example 3 match yet, but the indexes do. So since my indexes all match, I'm going to go ahead and try to break down these radicals and try to get them all to have the same radicand. So this first one is 5. That won't break down at all. So that's just going to remain negative 8 times the cube root of 5. Because there's nothing times itself 3 times, which will give me 5. So that's as far as I can break it down. Now I'm going to break 40 down. 40 will break down into 8 times 5. 8 will break down, since it's cube root, I know I need 3 to bring 1 out, so it's going to be 2 times 2 times 2 times 5. All right, takes 3 to bring 1 out. 1, 2, 3. I'm going to bring 1 out. I'm bringing that 2 out. Leaving me with the cube root of 5. Looking at the last one, now we see we've got some matching going on. Let's look at the last one. Minus. We need to break down 135. Use your calculator and do some work. 135. I'm going to say divide by 9. That's nice. 9 times 15. Well, that's 3 times 3. 15 is 3 times 5. It takes 3 to bring 1 out. Look at this. 1, 2, 3. I'm going to bring that 3 out, and I'm left with the cube root of 5. Now we have the same radicands. So what we do is we use the numbers sitting out front, like the coefficients, and we combine them. But be careful because we have signed numbers. This is -8 and 2 and -3. All right, so -8, if I think about it just like the numbers, -8 plus 2 minus 3. Because I know it's going to be cube roots of 5 sitting at the end. -8 plus 2 is -5. -5 and -3 is -8. So my answer is -8 cube roots of 5. Okay. Let's look at example number 4. Again, right here, we're going to need to simplify. We have the same index. We just need to break down 50 and 8. Well, 50, this is square roots now. I know it's going to be 25 times 2 because 25 is 5 times 5, right? I'm not writing very well today. All right. So it takes 2 to bring 1 out. So I'm going to bring that 5 out. Now, when I bring that 5 out, I'm going to multiply it by that 2x. So 5 times 2x is 10x, leaving me with the square root of 2x, because that x stayed inside. Minus. Now I have to look at that 8. It's going to take 2 to bring 1 out. So if I come up here, 8's going to break down into 4 times 2, which is 2 times 2, and gives me 2. It takes 2 to bring 1 out. So I'm going to bring out a 2. That 2 will multiply by that -5. 5 times 2 is -10, leaving me with the square root of 2. Now I can also bring one of the x's out because I have 3 x's underneath. It takes 2 to bring 1 out, so I can bring 1 out, leaving 1 inside. Now, looky, looky, we have the same radicand with the same index. This says 10x times the square root of 2x minus 10x times the square root of 2x. That's a big fat 0. Okay? All right. Last one. Let's see if we can make this one pretty. Here we go. In the first one, the only thing I can bring out of this first one is an x. Because I have 2 x's inside, it takes 2 to bring 1 out, so that's going to become x square roots of 2. In the second one, I've got 75. I know 75 is 25 times 3. I like using 25 because I know 5 will come out of that 25, leaving me with a 3. But then I also have 1, 2, 3, 4 x's. Oh, what's going on with my pen today? So I'm going to bring 2 out because it takes 2 to bring 1 out. I'm going to bring out 1, 5, and I'm going to bring out 1, 2 x's. So this is going to become 5x squared, leaving inside a 3. Okay. Get rid of that so I can write over here because it's getting a little crowded. Now I've got my -2x squared minus 3. I can't do anything with that, so I'm just going to leave that like that. And then minus, I've got an 18 inside there. I'm going to break that down into 9 times 2, which is 3 times 3 times 2. takes 2 to bring 1 out, so I'll bring 1 3 out. I have an x outside already, leaving me with a square root of 2. Now let's see what we can combine here. I can combine x square roots of 2 and negative 3x square roots of 2. That leaves me with negative 2x square roots of 2. Again, think of your square roots like variables and then just combine the numbers or variables that are out front, remembering to pay attention to your signs. Now I have a cube root and another cube root. So I've got positive 5x squared minus 2x squared. Negative or positive 5 and negative 2 is positive 3x squared square roots of 3. And that's it. That is your lesson. Here's your assignment for tonight. Join me in the Zoom classroom. We'll work through these. We will work through all of them if we need to. But that's a time where you can get guidance from me. You can do trial and error, and then try it. And if you mess up, you can ask me, hey, what did I do wrong? All right. Have a great day.